Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. So my name is ZULHILMI bin AZIZ. So this is my picture as you can see here, and my ID number. So this is my proposal presentation for my final year project 1 under part 7. So the title is Determination of Silica Content from Oil Palm Trunk via Incinerator Combustion. The title I get from my supervisor, Prof. Aida Mahat, which is conduct me under his team, under her team. So the project summary. The project will be carried out to study the content of silica in oil palm trunk, or we call it OPT. So this project was conducted with the guidance and direction of the project supervisor, which is Prof. Aida Jumaat. The main objective is to determine the silica content in oil palm trunk and come out with the result and data that prove oil palm trunk can be used as a source to extract pure silica from it. The idea is to burn the oil palm trunk through incinerator combustion process, which is the first process, to get the ash and characterize using X-ray fluorescence, XRF, X-ray diffraction, XRD, infrared spectroscopy, FTIR, and scanning electron microscopy, SEM. And to further the study of the silica in the oil palm trunk, the ash then used to run the chemical extraction process to gain the pure silica, and the result will be compared with the incinerator combustion process result. So basically, my project have two processes, which is the incinerator combustion process and the chemical extraction process. So next we go to the introduction and background. So firstly, we need to know what is silica. So here is the definition of the silica, or the introduction for silica. Silica, also called silicon dioxide compound it is a compound of the two most abundant elements in the crust, silicon and oxygen. So the short term is SiO2. The mass of the crust is 50% silica. The main constituent of more than 95% of the non-rock. As we know, rock that we can see usually contains silica in it, 95%. Three main crystalline varieties: quartz, tridymite, and cristobalite. Silica used in welding and road in the form of Portland cement, concrete, and mortar, as well as sandstone. So cement that we usually see at construction contains silica in it. Concrete, mortar. Also used in grinding and polishing glass and stone, in foundry mold, in the manufacture of glass, ceramic, silicon carbide, and silicon as a refractory material, and as gemstone. Silica gel is often used as desiccant to remove moisture. As you can see, the picture I used to put here, this is the silica powder. So what is incinerator? So as you can see here, this is an incinerator machine, UiTM incinerator machine at the Faculty of Civil Engineering. So incinerator is a container for burning refuse or plant designed for large-scale refuse combustion. Consists of a furnace into which the refuse is charged and ignited, usually by gas burner. A secondary chamber in which burning the refuse at high temperature is continued to complete the combustion process, and fuels to convey the gas to a chimney. Auxiliary equipment may include steam boiler for using waste heat to generate electricity or to heat nearby building. But in this project, no, there's no boiler for waste heat to generate electricity. Modern incinerator may include air pollution control equipment. As the incinerator that I use in this project, it has air pollution control equipment, the chambers and so on. So oil palm trunk, the main material in this project. So oil palm trunk is a solid waste obtained in large quantity after felling of oil palm trees and is available year round. As you can see here, the oil palm trunk is on the ground here. Scientists and industrialists face difficulty in utilizing the solid waste for different applications due to great variation in their physical and mechanical properties. Oil palm trunk has become one of the most valuable commercial cash crop in Malaysia. As you know, Malaysia, we have Prisda, Felda, a lot of oil palm. Abundantly available and it is less expensive. So, what is the problem with the oil palm trunk? So, here the problem statement for this project. So the first problem is the process of manufacturing of high purity silica is energy intensive and create various environmental problems such as pollution and emission of carbon dioxide. So as we know, manufacturing of high purity silica, for example, Portland cement, energy intensive, and the main energy that they use heat energy usually. And when they use heat energy, of course, air pollution and emission of carbon dioxide. So the second problem is there another low cost and better way to get silica? So we run this project to know that is there another low cost and better way to get silica? And it is the use of oil palm trunk as another option to get silica is worth choice rather than discussing. As we know, there are more agriculture waste outside there, such as rice husk, bamboo cane. Later I will show the example. So the question is, oil palm trunk, is it better? Is it the wise choice rather than disposing? So the objective is, first objective to the project is to determine the silica content in oil palm trunk through incinerator combustion using SRF, XRD, FTIR, and SEM. The second objective is to evaluate the effect of different acid type. So I use 3 acid type here: citric acid, acetic acid, hydrochloric acid in extraction of higher purities of nanosilica. And the third one is to determine the effect of acid concentration: 0.5 mole, 1 mole, 2 mole, and 3 mole, and operating temperatures, which is 25 degrees Celsius, 60, 80, and 90 degrees Celsius on nanosilica quantities during chemical extraction process. So for the scope and limitation in this project, the material I use is OPT, oil palm trunk. The process, two process, including two process: incinerator combustion process and chemical extraction process. So the first, we run the first process, and then the second. The testing, X-ray fluorescence, SRF, X-ray diffraction, infrared stereoscopy, FTIR, scanning electron microscopy, SEM. So go to the methodology of the research, the project. So 5 stages of conducting the research. The first one, material collecting. Second, we go to incinerator combustion process after we get all the material, and then after the combustion process, we get the ash. We do the chemical extraction from the ash that we get from the incinerator combustion process, and finally we do the characterization to see the characteristic of the silica that we get. So the final report writing. So the first one, material collecting, I use the Google Scholar and SciDirect to get the material I used to read and research. For the OPT, it will be taken from Pelajengka and will be directly sent to the ATM Shah Alam to research. If we don't get from ATM Silica, maybe from another place, another felder maybe. For incinerator combustion process, as you can see here, this is the incinerator combustion process at the UiTM. The incinerator need to be cleaned first inside and out using a broom. Firstly, it necessary to ensure that all incinerator components are in good condition and can function properly. In addition, the storage water tank must be also ensured to have sufficient water. Among the important components are thermostat, blower, and panel. To turn on the incinerator panel, of course, the panel need to turn on the switch, all the switch, the blower, thermostat, pump, the gas burner, insert into the two hole. The main fuel, which is wood, is add to increase the temperature to 600 degrees Celsius. Once the temperature reach 600 degrees Celsius, OPT is add and burn until it become white dust. For the chemical extraction process, you can see in this flow chart. Under chemical extraction process of silica, we have 3 processes, which is the first is acid leaching pre-treatment, second alkali treatment, and the third is sol gel treatment, which also known as the titration. First one ratio 1:3, the second one ratio 1:4. Under steering condition for acid leaching pre-treatment, 1 hour, temperature 80 degrees, wash, and then centrifugation. At the final of acid leaching pre-treatment, we get the dry acid treat waste. So from this waste, we use this waste to do the alkali treatment, and from alkali treatment, we get the sodium silicate solution. From this sodium silicate solution, we use to do the sol gel treatment, and finally we get the silica powder here. For the characterization, as you can see here, this is the old machine. This is XRF machine, XRD machine, FTIR, and BET. All the machine is in UiTM Shah Alam, under the School of Chemical Engineering, or Faculty of Chemical Engineering. So SRF we use in order to measure the chemical composition of the OPTH, acid treat OPTH, and silica. For SRD, we use to analyze the crystal structure of OPTH, acid treat OPTH, and silica. For FTIR, we use to analyze the functional group like hydroxyl, carbonyl, carboxyl, alkyne, and alkene in the sample. For BET, or the name is Bruno Emmett Taylor. We use to determine the specific surface area of the sample. So for the number 4, expected result. So this is OPT before incinerator combustion process, and next is OPT, and this is what I get after the combustion process. It black in color. The ash is black, but the expected result after the incinerator combustion process used to be like this. The ash must be white. Maybe because of the temperature was not enough at the incinerator that I do. Maybe it need to be more higher temperature, so it will become like this. This is so result on past study, as we can see here on in the table. Oil palm ash, it have silicon dioxide, also known as silica, 40% until 80%. The most highest rice husk. So a study on the ash content of oil palm suggests that silica concentration is roughly 46%. But another study on oil palm fuel ash, or PFA, found that it contains a lot of silicon dioxide, silica, 73% to be exact. So as you can see here, sugarcane base, silica percentage of silica, bamboo leaf. So my expectation is the silica content in OPT is here from 60 until 80. Not over to rice but more than bamboo leaf. So the figure, this figure show FTIR spectra of commercial silica and silica synthesized from acid leach or PFA. OPFA is this one of PFA, oil palm fuel ash. So same with OPT. So as we can see here, the graph, the result on spectra show the commercial silica and silica synthesized from acid leach or PFA have substantially identical spectra or same spectra. It has the same spectra. So peak 1, 2, and 3 represent three almost identical spectra. For the orange, acid leach of silica, and blue one is commercial silica. This FTIR spectrum finding provides considerable evidence that the chemical composition of the synthetic silica made from acid leach of PFA is similar to that of commercial silica. So this shows that in this project, maybe the result of the silica that I used to extract can be used to as same as the commercial silica. So that's all from me. Thank you. My email are here, my student email, and my number phone are here. So for any question, you can call or email me. Okay, thank you.